Welcome to Summarize Science. Have you ever wondered if an AI can imagine where it is in a room just by reading descriptions? A new study explores if large language models can understand viewpoint rotation without any visual input. For humans, it is easy to imagine turning left or right and knowing what we would see next. However, researchers found that current AI models struggle significantly with these mental maps. The researchers created a test called VRUBench to see how well AI could track its position through multiple steps. Models were given textual descriptions like, turn to the right by 90 degrees, and asked to predict what they would see. While a human can easily hit 100% accuracy on these tasks, most models fail to keep up after just a few turns. Even the most advanced models currently only reach about 60% accuracy. This chart shows the massive gap between human spatial intelligence and the current state of AI. Interestingly, models that were trained with visual data performed better on these text-only tasks than models that only ever saw text. This suggests that seeing images helps the AI build a better internal understanding of how space works. To figure out why AI gets lost, the researchers peeked inside the model's brain using a technique called path patching. They discovered that the information about the turns is actually present in the model's early layers. The AI knows it has turned 90 degrees, but it fails to bind that new position to the correct object it saw earlier. The study identified specific attention heads that act like specialized workers for spatial tasks. One head acts as a proposer to gather possible answers, while another makes the final decision. They even found an unknown head that seems to make the AI act extra cautious. This head often makes the model say unknown instead of taking a guess, likely due to safety training. Instead of retraining the whole model, the researchers tried selective fine-tuning on just these specific heads. By focusing on only these spatial workers, they improved the model's performance without causing it to forget other skills. This method is much more efficient, requiring only half the computing power of traditional training. Here is an example where the model successfully reasoned through 3 different turns to find the right object. It shows that when the AI uses a think-then-answer approach, its logic becomes much clearer and more accurate. Let's recap the big findings from this interpretability study. AI models currently have a hard time mentally rotating through a room, but the data to do it is hidden inside them. By identifying the specific parts of the model responsible for space, researchers can fix them directly. This shows that training in one format, like vision, can actually help an AI perform better in another, like text. In the future, this could lead to AI that can navigate complex physical or virtual worlds just as naturally as we do. It might also help us build smarter robots that can understand their surroundings through simple verbal instructions. Thanks for watching Summarize Science, and stay curious about the world of AI.